How humans might live on Mars. For centuries, humanity has looked to the stars, dreaming of setting foot on other planets. Among these celestial bodies, Mars has captured the imagination of scientists, engineers, and explorers. As Earth's closest neighbor capable of hosting human life, Mars presents a compelling yet formidable challenge. While the journey to Mars is a feat in itself, the question remains: how will humans live on the red planet? The environment of Mars. Mars is vastly different from Earth. With an average temperature of -80 degrees Fahrenheit, -60 degrees Celsius, a thin atmosphere composed mostly of carbon dioxide, and no breathable oxygen, survival on Mars requires advanced technology. The planet's surface is barren, rocky, and bombarded by radiation due to the lack of a magnetic field. Despite these challenges, Mars offers valuable resources, such as water ice and minerals, that could support human habitation. 2. Establishing habitats. Creating safe and sustainable habitats on Mars is crucial. These habitats will likely be pressurized domes or underground structures that shield residents from radiation, extreme temperatures, and micrometeorites. Materials and construction. Martian habitats might be constructed using materials transported from Earth or sourced locally. For example, scientists are exploring the use of Martian regolith, the loose surface material, to create bricks or concrete. Inflatable modules could also serve as temporary shelters until permanent structures are built. Life support systems. Advanced life support systems will regulate oxygen levels, manage carbon dioxide, and recycle water. Plants may play a dual role, providing oxygen through photosynthesis and supplementing the food supply. 3. Food and agriculture. Transporting food from Earth to Mars is impractical for long-term survival. Instead, humans will need to grow their own food in controlled environments. Martian greenhouses. Greenhouses equipped with artificial lighting and temperature controls could allow crops to grow in the Martian soil, which must first be treated to remove toxic chemicals like perchlorates. Hydroponic and aeroponic systems, which don't rely on soil, are also promising solutions. Diet. Early settlers may rely on nutrient-dense foods like algae, potatoes, and other crops that require minimal resources to cultivate. Lab-grown meat could also become a viable option as technology advances. 4. Energy sources. Reliable energy is essential for powering habitats, life support systems, and research equipment. On Mars, solar energy will be the primary source, as the planet receives sufficient sunlight despite being farther from the Sun than Earth. Solar panels. Solar panels will be deployed to harness energy, but dust storms on Mars can obstruct sunlight for weeks. Energy storage systems, such as advanced batteries, will be necessary to ensure a continuous power supply. Nuclear power. Small nuclear reactors could provide a stable and consistent energy source, especially during long dust storms or Martian winters. NASA is already developing compact nuclear reactors for use in space missions. 5. Water supply. Water is a critical resource for drinking, food production, and various industrial processes. While Mars lacks liquid water on its surface, significant quantities of water ice exist beneath the ground and at the polar caps. Extraction techniques. Advanced drilling technology will be required to extract and melt this ice. Additionally, researchers are exploring methods to extract water from the atmosphere, which contains trace amounts of water vapor. Recycling systems. To maximize efficiency, habitats will incorporate closed-loop systems that recycle wastewater from showers, sinks, and even urine into clean, drinkable water. 6. Transportation and mobility. Once on Mars, settlers will need vehicles to explore and transport resources. Rovers. Mars rovers, such as those currently used for exploration, will be adapted for human use. These vehicles will be pressurized and equipped with life support systems, allowing humans to travel long distances across the Martian terrain. Spacecraft. Landing and taking off from Mars will require advanced spacecraft designed to withstand its thin atmosphere. Reusable rockets, like SpaceX's Starship, are being developed to transport humans and cargo between Earth and Mars. 7. Health and safety. The Martian environment poses significant health risks, from radiation exposure to the effects of low gravity. Radiation protection. Prolonged exposure to radiation increases the risk of cancer and other health issues. Habitats will be equipped with radiation shielding, such as thick walls made from Martian regolith or water-filled barriers. Gravity. Mars gravity is only 38% of Earth's, which can affect muscle strength and bone density over time. Regular exercise and resistance training will be vital to counteract these effects. Medical facilities. Advanced medical equipment and telemedicine systems will be essential to address health emergencies. Settlers will also need training in first aid and basic medical procedures. 8. Psychological challenges. Living on Mars will test the psychological resilience of settlers. Isolation, limited communication with Earth, and the harsh environment could lead to stress, anxiety, and depression. Community and recreation. To fostering a sense of community will be crucial. Shared meals, group activities, and celebrations can help combat loneliness. Virtual reality systems may also provide entertainment and simulate familiar Earth environments. Training and support. Before embarking on the mission, settlers will undergo rigorous psychological training to prepare for the challenges of Martian life. Continuous support from Earth-based teams will also be vital. 9. Society and governance. As human presence on Mars grows, questions about governance and societal organization will arise. Laws and ethics. Mars settlers will need a legal framework to address property rights, resource allocation, and conflict resolution. International cooperation, similar to agreements governing the International Space Station, may serve as a model. Culture. Over time, Mars may develop its own unique culture, influenced by the shared experiences and challenges of its settlers. This culture could reflect humanity's adaptability and resilience. The road ahead. The dream of living on Mars is closer to reality than ever before. Space agencies like NASA and private companies like SpaceX are making significant strides toward this goal. While the challenges are immense, they are not insurmountable. Human life on Mars will require innovation, collaboration, and determination. By overcoming these challenges, humanity will not only expand its horizons, but also gain valuable insights into sustainability and resilience that can benefit life on Earth. The journey to Mars represents not just the next step in space exploration, but a testament to human ingenuity and the enduring spirit of discovery.